Hello everyone, I am Chandana. I am currently pursuing first year engineering in Sri Venkateshwara College. Today I am going to give a presentation on polar curves. Let us come to the introduction to polar curves. Polar curves are a way of representing equation and graphs in polar coordinates, which use a different systems than a familiar Cartesian coordinates x and y axis. Instead of describing points on a plane using x and y coordinates, polar coordinates use a distance r from the origin pole and an angle theta from a reference direction, usually a positive x-axis. In polar coordinates, a point is represented as r, theta, where r is the distance from the origin to the point and theta is the angle measured counterclockwise from the reference direction. Polar curves are the graphs of equation involving r and theta. They can represent various shapes and patterns including circles, spirals, cardioids and other intricate designs which may not be as straightforward to express using Cartesian coordinates. Equations of polar curves often take forms like r is equal to f theta, where r is a function of theta, defining how the distance from the origin changes with an angle. Understanding how different functions of theta affect the shape of the curve is essential in analyzing and graphing polar curves. To plot polar curves, one commonly uses value of theta within a certain range to calculate corresponding values of r and then plots these polar coordinates on a polar grid, where the angle theta determines the direction and r determines the distance from the pole. Exploring polar curves can reveal beautiful symmetries, interesting patterns, and unique geometrical properties that might not be immediately apparent in the Cartesian coordinate system. They are particularly useful in physics, engineering, and various fields of mathematics, especially when dealing with problems involving circular or symmetric patterns. Let's come to the common type of polar curves like cardioids, lemicons, and lemniscates, rose curves, Archimedes spiral. And here graphing polar curves. Cartesian curves are useful to describe paths in terms of horizontal and vertical distances. Polar curves are more useful to describe paths which are an absolute distance from a certain point. One practical use of polar curves is to describe directional microscopic patterns. And here we can see the different types of polar curves. Firstly, circle and cardioid, one loop lemicon, inner loop lemicon, lemniscate, rose curve. There are two types and one uneven and an odd. And last one, Archimedes spiral. Let us come to the significance of polar curves. Polar coordinates are used often in navigation as the destination or direction of travel can be given as an angle and distance from the object being considered. For instance, aircraft use a slightly modified version of polar coordinates for navigation. And let's come to the applications of polar curve. Art and architecture. Artists and architects use polar curves to create intricate designs, patterns, and structures such as spirals and circular motifs. Motions analysis. Polar coordinates can be used to describe the motion of object in circular or rotating system, such as amusement park rides or sport equipment. Limitations and challenges of polar curves. One of the advantages of using polar coordinates for circular shapes in that they can simplify the equations and calculations involved. For instance, if you want to draw a curve with a radius of 2 units, you can use the equation x equal to 2 plus and y equal to 2 equal to 4. Cartesian coordinates or the equation r is equal to 2 in polar and here significance of polar curves, whereas Cartesian curves are useful to describe paths in terms of horizontal and vertical distances. Polar curves are more useful to describe paths which are an absolute distance from the certain point. One practical use of polar curves is to describe directional microscopic patterns. Thank you everyone.